This is example 8b on page 93 of the workbook. And just to remind you of the instructions, they were asking us to take the series and to use the limit comparison test to determine whether it converges or diverges. So this is the same type of a problem as what we did in 8a a minute ago. Okay, so we'll approach this the same way by starting off doing a little scratch work here. Okay, so we'll start with the term in our series, 3n over 2n squared plus 4n plus 1. Okay, and the idea, again, is to take that somewhat complicated term in our series and see if we can find a simpler series that's related to it. Okay, and the idea is to just look at dominant terms again. Okay, so if you look at the numerator and the denominator, there's just one term in the numerator, 3n, so we'll take that. And in the denominator, which term is dominant? Which is the most important? We've got three of them. Okay, well, the 2n squared, that's the one that's going to grow the fastest, and so that's the one that really matters. Okay, and so what we're going to do is to just take the two terms that we circled, and we could take 3n over 2n squared, but it's customary to ignore the coefficients. The 3 and the 2, those multiples aren't really important. We're just going to take the n and the n squared. Okay, those are the dominant terms in the top and the bottom. Notice that we can simplify that a little bit. If we cancel the n in the top, that simplifies down to 1 over n. Okay, and so far what we have are the two terms in the series that we generally call bn and an, okay, when we use the limit comparison test. And the next step is to ask ourselves, do we know whether the series an converges or not? Okay, let's look at that on the side over here. Okay, well, what kind of a series is 1 over n? Okay, that's not a geometric series, but it is a p-series. Okay, remember that a p-series was a series that had kind of the form 1 over n to the p. Okay, in our case, the p is just 1 because n is n to the first. Okay, so this is a p-series with p equals 1. And if you look back at the p-series test a couple of videos ago, a p-series diverges if p is equal to 1. Actually, if it's less than or equal to 1. Okay. And the next part of the limit comparison test is we need to do a limit of bn over an. Okay, so we need to take the bn that we've got, which looks like 3n over 2n squared plus 4n plus 1, and we need to divide that bn by the an up here, the 1 over n. Okay, but to divide fractions, remember that we multiply by the reciprocal, so I'm going to skip one algebra step and jump straight to multiplying by the reciprocal of an, which would look like n over 1. That's just the flip of 1 over n. Okay, there's the limit that we need to calculate. All right, so from here, it's kind of algebra. 3n times n is 3n squared. Okay, and in the bottom, we're just going to get 2n squared plus 4n plus 1. Okay, as will often be the case, notice that that limit has the form infinity over infinity, so we can use L'Hopital's rule to calculate it. All right, so if we take the derivative on the top, derivative of 3n squared is 6n. Down on the bottom, we're going to get 4n plus 4, but that's still an infinity over infinity limit. We need to use L'Hopital's rule one more time. And now on the derivative of the top, derivative of 6n is 6, and the derivative of 4n is 4. And so we get down to just 6 over 4 numbers, which reduces to 3 over 2. Okay. And that 3 over 2 that we just calculated, that's the number that we refer to as c when we're using this test. Notice that that c is positive and finite, and that's what we want. That's a successful limit comparison test. Okay, so here comes our proof. We're just going to explain all of the pieces, the calculations that we did above. Okay, so starting with the calculation of c, that's a positive and finite number. The next thing that was important is the series an, okay, 1 over n. We notice that that's a divergent series. A divergent p series because of the fact that p was 1. The conclusion is that the series we were given, okay, way up here at the top, is also a divergent series. Okay, and to avoid having to write out that whole series over and over again, I'm just going to write the given series diverges. That's a shortcut that you can feel free to use. Given series just means the series that we were given in the problem.